Hi, this is Mr. Mitchell with a video about falling objects. We just touched on it a little bit about how objects, when they fall, there's kind of a misunderstanding or a misnomer, you might say, about heavy objects and lighter objects and the rate at which they fall. Here we have what looks like two equally sized objects, but this is a basketball on the right and a medicine ball on the left, which is considerably heavier. It has more force than the basketball does. However, one would think that something with more force would fall faster, and that is just an old idea. It's something that generally scientists believe the claim that two objects that are of different weights would fall at the same rate. So even though you have more force on the medicine ball because it's heavier, the medicine ball also is harder to get going. It has more inertia, kind of like pushing on a real old heavy car as opposed to a little bitty new car. It'd be harder to get the old heavy car to going, and that force and inertia kind of balance themselves out. And many years ago, Galileo went to the top of the Leaning Tower of Pisa, as so the legend says, and dropped two different sized cannonballs, and they both hit at the same time to try to give some evidence to this claim. So if we think about a falling object, the object accelerates due to gravity at 9.8 meters per second squared. Now keep in mind, I think we've mentioned before, this is acceleration, that the ball or whatever this lady is dropping will go faster each second. And I like this depiction, how it starts out a little slower, but will go faster each second after that. And what we'll find out today is that there's an exception to that, I guess you might say, here on Earth because of the air. But anyway, I had a pretty good graphic here. I wanted to show you that we have acceleration due to gravity, and you can see that this is not dropping after every second. This softball is not dropping 9.8 feet or meters every second. This is its speed after every second. So you can see the speed is increasing every single second at 9.8 meters per second. So after 4 seconds, you can see its speed is 39 meters per second, and after 1 second, it was only about 10 meters per second. So that's going to be the same for a softball, a gumball, or even a wrecking ball. It's all going to fall at the same rate. But there is something to factor in, and that's called air resistance. Air resistance is the friction-like force that opposes the motion of objects that move through the air. So a falling object has air resistance pushing up against it. Now here on the Earth, we have this layer of air. So if something is dropped from an airplane, it has to go through the air, and you're going to have the force of, in this case, the skydiver going down, but you're also going to have the force of the air coming up against it. If you drop this lipstick case, it would be the same thing. However, notice that the surface area is different for this lipstick case than it is for this person who is falling through the air. So this lipstick case would not have as much air resistance as it is falling because of the lack of surface area. So the amount of air resistance does depend on the object's shape, on the object's size, and at the speed at which it is falling. So if this person just jumped out of the airplane, it's not getting as much air resistance at first, but when it starts traveling very fast, it's getting more air resistance. So if you have this coconut that somebody, for some reason, threw out of a plane, it would have less air resistance at first, and it would have a lot of air resistance at last. Now, what's going to happen is you're going to have a point at which you're going to have just as much force going up as you have force going down, and the object will no longer accelerate. Now, you may remember that we said right here that after every second, it has accelerated even more. But if you have more and more force that is pushing up against it, more and more air resistance, it is going to have it at a constant speed at some point. Of course, this coconut is not ever going to stop as it's falling through midair, but it will accelerate it first, and at some point it will reach its terminal velocity. The terminal velocity is the maximum speed an object will reach when falling through a substance, such as air. And every object has a different terminal velocity. The coconut would have a different shape and size as the person, as the lipstick, and of course as the feather. The feather, of course, has so much air resistance against it because of its shape and because of its lightness. It is very light, probably not much more lighter than a lipstick case, but the shape just really puts a lot of air up against it. So suppose an object were falling with no air resistance, that you did not have air coming up against it. And there's only a couple of situations where that would be the case. In a vacuum, you may have seen this famous video where a feather and a bowling ball were dropped in a vacuum. A vacuum has no air in it. That's a big chamber where air has been taken out. And of course, the feather and the bowling ball hit at the same time. Or unless you're in space. Now, if you're in space, you do have gravity out there, but the Earth has moved away as this person is falling. So they are in a state of free fall. And that's exactly what you have when you have something that is falling and there is no air resistance. That means gravity is the only force acting on the object. You have no air resistance happening. And you call it in free fall. If an object's dropped in a vacuum, there's free fall. If an object dropped in space, there's free fall. And this is sometimes referred to as weightlessness because weight is a force. Truly, these masses have not changed. The bowling ball still weighs more than the feather, and this person in the suit still weighs whatever or still has the mass of whatever it was. But the scales that you normally would step on, for example, are on Earth, and they are not falling if they are on Earth. But if you put this guy or girl on a set of scales, the scales would be falling also. So you could not really even get a measurement from it. The weightlessness does not mean there is no gravity or mass. It's just that the objects happen to be in free fall. So in class we're going to do some work with some stuff in free fall, and I hope you've learned a little bit about the terminology.